Okay, so this is a video presentation of the implementation of a C++ program using dev C++ that follows the algorithm of a fixed point iteration in solving the roots of some nonlinear functions and or can be transcendental functions. Then we also have the Gauss-Seidel method that is used in finding the solutions of simultaneous equations. And lastly, the Lagrange interpolation that is also used in estimating the intermediate values between precise data points. So first, let us look at the fixed point iteration. So this is the source code, the C++ source code for the fixed point iteration. So the first part is this is for the library. Then the program here, we need to input our function or the equation of the function. And we need to write it into the form of x equals g of x. We need to find that g of x first. And we need to input that or write that here in this space here. And we need to make sure that the first derivative of that function should be less than 0 for convergence. Then the program will be asking different inputs. The first one is the initial guess for the iteration. So this is a non-bracketing method, so we can choose any initial guess. Then also the tolerable error or the stopping criterion. Then here, there's a maximum iteration that is also included to make sure that when the program or when the number of iteration is now greater than that maximum iteration, then the program will tell that the problem is not convergent. And after that, we have the root of the equation. So let's try to implement this into the dev C++. So this is our actual IDE or the interface for a dev C++. So this is our source code again. Then I already inputted or written the function here. Then I did choose this form x equals gx for that function. Then we can now run this by clicking near compile and run or pressing F11. So this is now compiling. Then after that, we will be here in the MS-DOS Windows. So we need to enter the initial guess first. So let's take 0. Then the tolerable error for the problem. So we have a problem here. Let's take this problem. The output voltage on a given function's generator with a varying phase angle is given and determine the magnitude value x that will output a value of -10 volts using fixed point iteration method in dev C++. So our stopping criterion is 0.0001. So we need to include that here. So our tolerable value or error will be 0.00001. Then we can choose any maximum iteration that you want. We can choose 10. Then this will be the result. So the result is the root of that equation, that function, is 2.699669 with a tolerable error equal to 0.00007, which is less than the indicated stopping criterion. So that is a fixed point iteration using dev C++. Next will be the Gauss-Seidel method. So this is the source code for the Gauss-Seidel method. So again, we have different inputs that will be asked by the program. The first one is the number of equation. We need to input the number of equation. If we have 3 equations, 3 unknowns, or 4 equations, 4 unknowns, or more than that. Then after that, we need to enter the elements of the augmented matrix row-wise. So we need to input the coefficients of the equations, the simultaneous equations. We also need the initial values for the variables. You can choose 0, 0, 0 if you want. And again, the stopping criterion or the tolerable error. Then here, the last part of the source code. So this will be the solution. It will display the solutions for the simultaneous equation. Now, you demonstrate this. So this is an example. Evaluate the derived system of linear equations from a given nodal analysis circuit using Gauss-Seidel method in Dev C++, using terminating condition of less than 0.0001 for each variable. So these are the system of equations. So this is three equations, three unknowns. So if we need to implement this into the Dev C++, so this will be our source code for the Dev C++. Now we can now run this. And this will be the program. So first, enter the number of equations. So how many equations do we need to solve here? We have three equations. So we input 3, then enter. Enter the elements of the augmented matrix. So this is already arranged. I1, I1, I2, I2, I3, and the constant side. So we can just follow that. So we have first 5, then press tab for the second column, 3, the coefficient of I2, then the coefficient of I3, negative 7, and lastly for the constant, 0. So that's the first equation. Then press enter. Then for the second equation, the coefficient of I1, 3, press tab, negative 5, then positive 2. Then we have for the constant, negative 8. Then lastly, for the last equation, we have 7, then 5, then we have negative 3, then we have 16 for the constant. So this is now our augmented matrix. So then press enter. Then we need to enter the initial values for the variables, so we can just choose 0, 0, and 0 for the initial values for the solution, and press enter. Then next is the stopping criterion, which is 0.00001, and press enter. So this is now the solution for the equation, simultaneous equation. So we have here 0.9996 or 1, 3, and 2. So this is the implementation of the Gauss-Seidel in Dev C++. Then lastly, for the Lagrange Interpolation method, so this is the source code. So this is a more complicated program because the program uses the class syntax here, and it uses different functions, different voids. But again, we have different inputs. The program will ask the first the number of values or the number of points for the interpolation. Then it also asks for the value of x to find the function. So what value of x we want to determine for the function. Then and so on. After this one, it will display actually the actual value for the function for the given x. So this is the source code. Now let's demonstrate this one by solving a problem here. An example. Apply Lagrange interpolation using Dev C++ to fit the given set of data points into a function and determine the force F at a distance x equals 9 feet. So this is the points. So we have how many points here? 1, 2, 3, 4, and 5. So we have 5 points. So this will be x0, x1, x2, x3, x4, f of x0, f of x1, and so on. So we need to determine f of 9 because we want to determine the force at x equals 9. So let's go to the dev C++. So this is our source code. Then we can now run this. Click run again. And here we are in the MS-DOS window. So what do we need here? We need to enter the number of values first. So how many values do we want? We want 1, 2, 3, 4, 5. So 5. We want 5 values, 5 points. Then enter the value of x to find f. So here given when x equals 9, what should be f? And we can now enter for the different data points. For x0, so we have the first one, we have 5. Then we have x1, we have 7. Then 11, press enter. Then after 11 is 13. Then enter. Then lastly 17 for the x. And for the f, for the forces, for the x0 we have 150. Then we have 392. Then we have 1452. Then 2366. Then 5202. And you're gonna press enter. Then this will be the result. So the value of f at x equals 9 is actually 810. So this is the Lagrange interpolation using dev C++. For my reference, lastly, for the reference, so these are the references that I used in formulating the program, writing the programs, and other things for the user guide manual of the programs. So that's all, and thank you.